We spend so much time obsessing over what we eat, right? Carbs, proteins, fats, the whole deal. But what if I told you that when you eat could be just as important, maybe even more so? Today, we're diving into the fascinating science of meal timing, and it's all run by a hidden clock that's ticking away inside every single one of us.
So let's start with a puzzle. Think about it for a second. You go to bed, you sleep, and you've gone a solid 8, 10, maybe even 12 hours without a single bite of food. Logically, you should wake up absolutely ravenous, right? But most of us don't. So what's the deal? If it was just about having an empty stomach, this would make absolutely no sense.
Well, the answer to that paradox has surprisingly little to do with how empty your stomach actually is. The real secret lies way deeper. It's all being run by an invisible timekeeper, a master clock that's quietly directing the show behind the scenes of everything your body does.
Right, so this invisible system is really a network of our body's internal clocks, and understanding these clocks is the key to unlocking this whole daily mystery of why we feel hungry when we do.
So these clocks are what drives something called circadian rhythms. You've probably heard the term, but what does it mean? Basically, these are your body's built-in 24-hour cycles that manage pretty much everything. When you feel sleepy, when you feel wide awake, when your hormones get released, and, most importantly for us right now, how your body actually processes food.
Now here's where it gets really cool. Think of your body like a giant orchestra. In your brain, you've got the master clock, also known as the SCN. This is the conductor. It sets the main tempo for the day, and its biggest cue is light. But then you have your organs, your liver, your gut, your pancreas. They each have their own peripheral clocks. They're the musicians in the orchestra. And you know what their biggest cue is? It's when you eat. For your metabolism to work perfectly, the conductor and all the musicians have to be playing in perfect rhythm.
Okay, so how does this whole orchestra of clocks solve our morning hunger puzzle? Well, it turns out the answer is literally programmed right into our biology.
And don't just take my word for it. Researchers at Harvard Medical School absolutely nailed it. They found that our internal clock has its own preset schedule for hunger, and it drives our appetite up in the evening completely separate from when we last ate or what we were doing. It's this powerful, independent rhythm.
And this is the proof, right here. This graph is from a study where scientists controlled everything: sleep, light, activity, meals, you name it. And what they found was this undeniable built-in rhythm to our appetite. You can see it clear as day. The peak, when we feel the hungriest, hits around 8 p.m. in our biological evening. And the low point, the trough, is right around 8 a.m. This is it. This is why you're not starving at sunrise. Your body's clock is actively turning your appetite down.
So that's how it's supposed to work. But what happens when our modern lifestyles, late dinners, shift work, midnight snacks, force us to eat totally out of sync with this natural rhythm? Well, as you can imagine, there's a serious metabolic price to pay for that kind of misalignment.
Here's the most crucial takeaway. Your body is just not the same machine at 8 in the morning as it is at 8 at night. In the morning, your metabolism is fired up and ready to go. You're more sensitive to insulin, which means you're super efficient at using sugar for energy. You even burn more calories just digesting your food. But as the day goes on, that system shifts. In the evening, your insulin sensitivity drops, and your body becomes much more geared towards storing energy as fat. The exact same meal can have a totally different outcome depending on what time you eat it.
And let's be honest, our modern world is just packed with things that throw this whole system into chaos. Eating late at night is a huge one. So is the crazy schedule of shift work. Even just having unpredictable, irregular mealtimes can confuse our internal clocks. And then there's a more surprising culprit.
And that's the blue light from our screens. Get this. One study found that just a few hours of exposure to blue light from our phones and computers in the evening can actually make us feel hungrier and make our bodies more resistant to insulin. So yeah, that late night scrolling you're doing, it might be doing a lot more than just keeping you awake. It could be directly messing with your metabolism. How wild is that? Okay, but it's not all doom and gloom. The good news is we can actually take back control. This isn't about fighting our biology. It's about learning to work with it. The solution is to resync our system. And the key, as we've seen this whole time, is all about timing.
One of the most powerful and effective ways to do this is a strategy called time-restricted eating, or TRE. The concept is actually really simple. You're not necessarily changing what you eat, you're just being consistent about when you eat. You just narrow all your eating down to a specific window each day, say from 10 a.m. to 6 p.m. This gives your body a really clear and predictable rhythm of feeding and fasting.
And the results from the clinical trials on this are just wow. They're incredibly compelling. TRE has been shown to lead to significant weight and fat loss, sometimes even when people aren't trying to cut calories. And the timing matters. Studies show that an earlier eating window is especially good at improving insulin resistance. It can even lower blood pressure on par with some medications and improve your cholesterol. It just works because it gets the whole orchestra, all those organ clocks, back in sync with the conductor in your brain.
So as we wrap this up, it really leaves us with a powerful question to chew on. In our endless search for better health, we focus so much on calories and macros, on what to eat and what to avoid. But what if the simple, powerful act of changing when you eat is the missing piece of the puzzle we've all been looking for? The science certainly suggests it's a question worth asking.